All right. Unit 2, Section 7. When examining the distribution data set, we generally look at the shape of the graph, the typical value, and the variation of the data values. First, let's look at the shape of the graph. Is it symmetric or skewed? The following is called a symmetric distribution or bell-shaped distribution. It says, how would you compare the left and the right sides? So they're symmetric. It says, how many mounds does it have? And so if you look, there's only kind of one peak there in the middle. The next graph is described as skewed. So how is this graph similar to the previous one? So there's one mound. Oops, oh my gosh. There's one mound. And how is this graph different from the previous one? If you'll notice that it's skewed, or it's leaning to one side. So it's leaning to one side or the other. It says we use the terms skewed right or skewed left to describe your graphs, and the graph is skewed right. Okay, so how do you think you could define skewed right? So skewed right, so you basically have your mound on the left, your tail on the right. So skewed right, you have the mound on the left, your tail, and later on we'll actually talk about what the tail means. Those are called outliers, or on the right. Okay, so describe each of the following graphs as symmetric, skewed left, or skewed right. So if I look at this graph and kind of just put a smooth graph over each one of these. Oops, that one didn't kind of connect right, but okay, this one you can kind of see the mounds on the left, the tails on the right. So this is skewed right. Whereas this one has your tail kind of on the left, your mound on the right. So this is skewed left. And then the one in the middle is symmetric. And I can't spell symmetric, obviously. A scenario that would produce a graph that is skewed right is an exam where most people scored very low, with only a few doing well. Describe a scenario that would produce a graph that is skewed left. So it would kind of be the opposite. So that would be an exam where most scored, instead of most people scoring very low with a few doing well, you have most scoring high with a few doing bad. So you have the opposite. So 10, look at more mounds. The statistical term for one mound is unimodal. Two mounds are both bimodal. What do you think the term bimodal means? So the term bimodal means two. So bimodal means two mounds. What do you think we mean when we describe a graph as multimodal? Oops. So multimodal means that you're going to have more than two mounds. And then what about a uniform graph? Basically means that all your values are the same. So everybody has the same y value, or the same frequency. So it's all the same frequency. So number 12, when we look at real data, it may be more difficult to identify the number of mounds. How would you describe the graph at the right? Unimodal, bimodal, or multimodal? And it really depends on how you kind of draw your graph. So the answer can vary. So you kind of see it dips down a little bit here, but it depends if you go down and come back up, or if you kind of do a smooth graph through it. Now this one dips down as well. So you could go down and come back up if you wanted to, but you also could just do one smooth graph through it and just do one over graph. So if I want to call it unimodal, I would just do a graph like this. If I want to refer to it as bimodal, I would kind of go up. And this is kind of significant here, go down and come down like that. If I want to refer to it as multimodal, I would be more specific and I would go up, come here, go down, and then even down here, go up and come back down. So it really depends on how you break it up and how specifically you want to go down into the little valleys. Okay, so let me get rid of this up here. It says estimate the bin size of the first graph. So this was the problem on the previous page. And I know this graph is kind of small and it's hard to see, but they want you to estimate the bin size. So I would start with the 200, because you can kind of see that it starts on this line, go from the 200 to the 300. And if you see between the 200 and the 300, there's 100 minutes that elapses within here. And there's 1, 2, 3, 4, 5 bars in here. So if I do 100 minutes divided by 5 bars, that's 20. Oh, that's a really bad 20. I'm going to say that the bin size is 20. Whereas on this one, it's kind of hard to see, but I'm going to go with the 100, and then the 300 here is directly in the middle. That's a time lapse of 200 minutes, and there's 1, 2, 3, 4 and a half. So that's 200 divided by 4 and a half bars. Let me get out my calculator. 200 divided by 4 and a half. That's about 44.4 for the bin size. So the bin size is just how wide is it. So how does the maximum value for the frequency change from the first graph to the second graph? So on the second graph, it gets, so your bin size is 20. So on the second graph, your bin size is wider, so it covers more. So your bin size is going to get bigger. So it gets bigger because you're almost putting together like these two bars almost. You're putting together almost the 40 and the 100. So you're not putting together them, but you're putting together 2 bars. So the frequency gets bigger because you're putting together more data together. How would you describe the second graph? Unimodal, bimodal, or multimodal? So the second one, I would call it unimodal. So you can kind of see that the same data, when you go from one graph to the next, if you make the bars wider, it smooths it out and it makes it unimodal. Explain how making certain decisions when constructing graphs can have an impact on how many mounds it will have. So the wider you make your bars, the more smooth you're going to have, because the wider you make them, the more data you can get in there. So so the wider your bin, the wider the bin, the more data in your bar, the more likely. Okay, hold on. I might need to squeeze this down. All right. I know this is not going to fit exactly, but the more likely you are to have a unimodal graph. We call extremely large or small values outliers. Outliers are important when describing a graph. They can be indications of errors while collecting and recording data. It's important to check for those errors, identifying the following graphs. So you look for the things where they're sticking quite out. So these are my outliers, but also these values here also might be outliers. So, but most definitely those are going to be your outliers. The next thing to look at is the typical value or the center of a distribution. So right now, without calculating it, when I ask for the center, you're kind of looking for the middle of the graph. So the histogram at the right shows the number of goals scored in 2012 by women who are the first year soccer players in Division 3, has reported that the graph has a center. Oh, jeez. I got to keep remembering to do the pen. Of 16. So that was your typical number of goals. So how do you think this decision was made? So that was made because 16 was about in the middle of your graph. So 16 is about in the middle. So it looks like about 50% was below, 50% was above. And so that's what they're looking at. That's kind of like in the middle bar right in here. It says, if you describe the center as 15, is that reasonable? In other words, do you think that is making this type of judgment subjective? Would everyone get the exact answer? So the first bar has 5, the next one has 9, this one has 1, this one has 1, this one has 6. So that's 14 in here. These two together have 6, 7, 8. So this bar in here has 6. So is it reasonable for the center to be 15? It's possible, because if the center is 15, that's kind of right in the middle. There's 8 there. If it's 15, that's kind of in the middle. That's reasonable. Do you think making is subjective? Not everyone will get the same answer. So it's reasonable. But no, because the 15 to 17 bar could also be ages 16 or 17 in addition. So it's reasonable, but it also could be in addition to 15 years old. So it's reasonable, but it also could be 15 to 17-year-olds for that. Okay, is 18 reasonable? I would say no, because you'd only have, at minimum, you'd have 2 from the little ones, and then you'd only have, at minimum, about 8 to the right of that. So I would say that's not reasonable. And 12, I would say it's possible, but only if that whole entire bar is all 12s. That whole entire bar is 12s. Complete the following to estimate a reasonable interval for the typical number of goals to describe the center of this distribution. So if I look at the distribution, I would say maybe like 13 to like, so the center, maybe like 13 to like 19, maybe 13 to 19. So we kind of just picked maybe like the middle 50% or so. We're just estimating. So just kind of estimate for right now. So the histogram at the right shows number of girls scored in 2012 by men who were first-year soccer players in Division 3. What is the typical number of goals scored for men? Estimate using an interval and write a complete sentence. So your typical goals, so there's 2 here. What is this? 1 here, 2 here, 7 here. So I would say probably a typical number is in here. So maybe about 12 to 14 is your typical number, because you kind of got 2 below, 3 above. So that's kind of in the middle ground for it. And then the variation is the last thing we're going to talk about. The last feature when examining the distribution is the amount of variation. Oops. So variation is just our fancy word for spread, like how far your data is spread out. For the 2 data sets below, family 2 has more variation in the height than family 1. So family 1, all their heights are about the same. So everybody has about the same height. So there's 4 people that have the same height. So there's 1, 2, 3, 4 people that have the same height. Whereas here, everybody has a different height. So they're all going to have a different height. So they're spread out further instead of just having one person. So what do you think variation basically means? So variation means that you have a wide variety of choices, of heights in this case, of results. They're vastly different. So family 1 has very little variation in height. Their heights range from probably maybe 69 to maybe 71 inches. And family 2 has a lot of variation in height, and they range from maybe about 44 inches to probably about 71 inches. Consider the following distributions showing the length of the stay at 2 resorts in the same chain. They each had about 30,000 guests over the last years. Which resort had more variation in the days guests stayed at the resort? So this one, oops, I keep forgetting to do this. This one had more variation. This one had a spike because more people stayed here. But this one had more variation because people stayed, even though it was 2 to 16 days, this one had more variation because they were spread out. So resort B, they were more spread out, more evenly, and they weren't clustered all in one spot like A was. All right, 19. Fill in the blanks in the description below to compare the distributions for the number of goals scored in 2012 by men and women who are first-year soccer players in Division III. So the distribution of goals is blank for women. Oh, dang it. Let me do this again. And so if I kind of look this, so for the women, I'm going to say this is skewed right. And for the men, I'm going to say symmetric. The women typically scored about, so I'm going to say about maybe about 13 to maybe 16 goals, while the men scored about 12 to 14 goals, not including an outlier in the, so there's an outlier here in the 33 to 35 bin. The variation in the number of goals scored by women was, so I went from 9 to 36 versus 6 to 21 was more than the number of goals scored by men. Okay, describe the distribution of body piercings for students in a statistics class. So this one you have to be careful of. This one, there's 45 students who said they had no piercings. There were probably about maybe eight or nine that said they had one. I want to say maybe 18 that said they had two, maybe about 6, 1, maybe 5, 6, 2, 1 that said they had 10. Okay. So it says, is this symmetric, skewed left or skewed right? And so if I kind of put a graph on this, this is skewed right. I'm going to say that this is unimodal. Write 1 to 2 sentences explaining what this means in the context about the number of piercings for the students in the class. We'll skip that part for right now. Oops, hold on. Let me erase that. Undo. Okay. I just want to move this. Oh, maybe not. Okay. Well, I guess I'm not going to be moving this up. Dang it. Okay. So it says, where is the center? Now, what you have to be careful of is between the 18, oh, I'm trying to point, between the 18 and the 6. Oh, I'm trying to point. Between the 8 and the 18 and the 6 and the 1 and the 5 and the 6 and the 2, all of that together probably makes up about the same, or if not even close to the 45 that's here. So when they ask you for the center is not going to be right here in the middle of the picture. Your center probably is going to be here between like 0 and 1. So when they ask where the center is, I'm going to say between 0 and 1. So because write a sentence explaining this in the context of the number, the typical number of piercings. So your typical number of piercings is between 0 to 1. Would you say that there's a lot of variation, some variation or little variation? There's little variation because you see that you have this one huge bar here with the 45. So there's not a lot of variation in the data for this.